Hi there, Year 10. We're going to build on the work we've been doing with quadratic equations and their graphs today, and we're going to look at two different types of graphs. And the reason for this is that students should have an understanding of the different shaped graphs that different equations create. It's incredibly useful for if you go on to do A-level maths and of course beyond if you continue with maths study or anything that involves maths, engineering, whatever. The two types of graph we're going to consider today are cubic graphs and reciprocal graphs on the next page. Now, cubic graphs are graphs of any equation where the highest power of x is 3. So, for example, this one. And now they may also have an x squared in them or just an x, but we're interested in the highest power of x. That's what determines the overall shape of the graph. And reciprocal graphs are any graphs. Are the graphs of any equation where x appears in the denominator of a fraction. And we'll see what they look like as well. Just a little reminder before we start cubic graphs that when we were doing quadratic graphs, when we squared a negative number, their answer was positive. But when we cube a negative number, it will be negative. So for example, if we cube -1, we are timesing -1 by -1, which at this point would give us +1. But then we're also timesing by -1 again, which will revert it back to being negative. Okay, so just a little reminder there before we start. Okay, you have to be good at substitution to do these. You're not expected to be able to look at the equation and know too much about it, although there is something we can take from this. Hopefully, having just done the lessons we've just done, the y-intercept will jump off the page at us because the y-intercept is when the x-coordinate is 0. But other than that, it's quite hard to just determine what these graphs are going to look like without using a table of values. So we need to be able to substitute well. Okay, let's get stuck into this one. So we've got a table here for this equation. We're going to fill in the missing numbers. Okay, might as well start with the positive numbers, easier. So 2 cubed would be 8, plus 2 minus 4 would give us a value of 6. When we substitute in 0. 0 cubed would be 0, plus 0 minus 4 would give us -4. When we substitute -1, it's sometimes worth just setting this up on your calculator, but just make sure you use brackets for any value you're going to go back and change, because there are issues with squaring and cubing negatives. Well, there aren't, but you may think that your calculator is giving you an incorrect value, but not if you use brackets. Okay, so -1 cubed would be -1, plus -1 would be -2, take away 4 would be -6. Okay, so now we're going to plot this graph. So 2 across, 6 up. I'm going to plot this now. Whoops. And you can just, it will appear in a minute. Okay, that's what that graph looks like. And then part C, use the graph to find the value of x when y is 2. So I'm going to draw a line across at y equals 2. Oh, sorry, that's the wrong one. And you can see that they intercept here. The value of x where that happens is, on my graph, approximately 1.65. Yours might be slightly different. So just use whatever value you've got. Okay, there is an exact answer to that, and we can find it using the equation or using a graphical calculator or an online sort of graphing tool, but for questions like this, they obviously give you a bit of leeway in an exam. Okay, let's have a look at question 2. So, again, no values given to us this time. We're going to have to substitute in and figure out these y coordinates. So let's start with the positive numbers. 2 cubed would be 8. Take away 2 lots of 2, which would be 4, plus 3, so that would give us 7. I like to try not to keep too much in my head when I'm doing these, so I like to write down certain bits. 1 cubed would be 1. Take away 2 lots of 1, which would be 2. That give me -1, plus 3 would be 2. When we substitute in 0, the answer will be 3. When we substitute in -1, -1 cubed would be -1. take away 2 lots of -1. 2 lots of -1 would be -2. Now, what I can do with these here is add. So -1 plus 2 would be 1, plus 3 would be 4. And finally, -2 cubed would be -8. 2 lots of -2 would be -4. So I've got -8 plus 4, which is -4, plus 3, which is -1. Okay, I'm going to plot these and now draw the graph. Okay, that's what that graph will look like. Now it's very hard to actually figure out where the turning points of these graphs will be. It might have seemed like it was at -1 and +1, but actually I just used an online tool to find out that it wasn't actually at -1 and +1, but close to it, just inside those two numbers. Now you're not expected to be able to just sort of figure that out, of course, and it doesn't really matter if you put the turning point at -1 and +1, but just for accuracy I've used the right value. Okay, let's have a look at number 3. Same again, lots of substitution first, so let's start with the positive numbers. 2 cubed would be 8, plus 2 lots of 2 squared. So let's start with the 2 squared bit, that would be 4. 2 lots of that would be 8. So 8 plus 8 minus 1 would be 15. Okay, 1 cubed would be 1. 1 squared would be 1. 2 lots of that would be 2. So 1 plus 2 minus 1 is 2. 0 cubed would be 0. 2 lots of 0 squared is 0, so this gives us -1. -1 cubed is -1. -1 squared is +1, and 2 lots of that are 2. So we've got 1 minus 1 is 0. Okay. -2 cubed is -8. Oops. -2 squared is 4, +4. 2 lots of that is 8. So this would give us -1. And finally, -3 cubed is -27. -3 squared is +9. 2 lots of that is 18. So this would give us -27 plus 18 is -9, take away 1 is -10. So I'm just going to plot this now and then draw the graph. And there's what that final graph would look like. Don't worry about this sort of way of writing these questions. It says draw the graph of the equation we've just found values for. It just says for the values of x, where x is greater than or equal to -3 and x is less than or equal to 2. So in other words, it means for the x values that were in the table and no more. Okay, but don't worry if you go a little bit further than those. Okay, but it just means those numbers. Okay, I'll do the next page on the next video. There's just one more thing I'd just like to mention before we move on, and that's that you probably noticed now that the general shape of a cubic graph is this kind of wobbly shape like this. For the most simple cubic graph, y equals x cubed, we would actually get barely a wobble in the middle. Okay, it would go kind of like that. Whereas if you change some of the values, maybe have some x squared values, change the numbers in front of them, you do actually accentuate this wobble in the middle. And if we have a negative x cubed graph, it will go the other way, a bit like our upside down parabolas for quadratic graphs. Okay, so negative x cubed graphs will wobble the other way. And I now wish I had included a few of those, so maybe I'll change the pack for next time.